This is SREB, ready for high school math, lesson 2.3b, solving multi-step equations. Okay, so we're going to revisit solving multi-step equations, just kind of a little bit of a recap. Okay, so keep in mind, multi-step equations, so far we talked about one-step equations, we've talked about two-step equations, and then multi-step is just anything more than just two steps. Okay, so let's just start with this first one, okay? First one, we got 3x minus 5x plus 7 equals 2x minus 9. Okay, so first thing you want to look for is, do we have any parentheses? Okay, so over here we don't have any parentheses to worry about. Next up, we need to combine all like terms on one side of the equal sign. Okay, so what I mean by that is we're going to look first at the left-hand side. We got 3x minus 5x plus 7. So any like terms on this left side we're going to combine together. So I'm going to take this 3x and this 5x and put them together. Okay, I'm just going to subtract the coefficients in front of the x's. So 3 minus 5 will give me negative 2x. And then the rest of it I'm going to rewrite as normal. So now I get negative 2x plus 7 equals 2x minus 9. So now from here, I want to get all of my variables on one side. So I've got negative 2x over here. I've got positive 2x over here. I want to have all of my x's on one side. So out of habit, I'm going to want to move all of my variables to the left. So I want to get this 2x over here to the left. Well, this is positive 2x. So to get the positive 2x on the other side, I need to do the opposite of positive 2x. And I need to subtract 2x. And anything I do to one side of the equal sign, I need to do to the other side. So subtracting the 2x, get it away from the right-hand side, and I get negative 4x plus 7 equals 2 x's over here cancel out, negative 9. Okay, now from here, I've got all my variables on the left side, so I want to get all of my constants on the other. So anything that doesn't have variable, I want to move to the right-hand side. So I've got plus 7. To undo plus 7, I'm going to subtract 7. Anything I do to one side, I do to the other. So this gives me negative 4x equals, because 7's cancel out, negative 9 minus 7. Now be careful when you type this in. You want to type it in as negative 9 minus 7, not negative 9 minus negative 7, okay? Because that'll be the opposite of what we're wanting. We need negative 9 minus 7 to give us negative 16. And then lastly, to get that x alone, we have negative 4 times x. So to undo that times, we're going to divide by negative 4 instead. And so we'll get that x is equal to negative 16 divided by negative 4, which will give us positive 4. Okay, and then to go back through and check, we would take this x value right here and we would plug it back into our original. Okay, so if I come over here and I check my value just to make sure this works, this would be 3 times x. I'm going to plug in 4 minus 5 times 4 plus 7 is equal to 2 times 4 minus 9. Okay, so we'd use order of operations. We would knock out the multiplications first. So that's 12 minus 20 plus 7 equals 8 minus 9. 12 minus 20 gives me negative 8 plus 7. 8 minus 9 gives me negative 1. Negative 8 plus 7 gives me negative 1. So when I get a statement like this, negative 1 equals negative 1, then that means that my value is good. So x does indeed equal 4. All right, number 2. 4 times 2 minus 1/8 p is equal to 1/4 p minus 7. So with this one, we do have parentheses. So to get rid of these parentheses, we need to distribute the number that is in front of the parentheses. Okay, so in this case, it is a positive 4. So everything that's in the parentheses on the left-hand side is going to get multiplied by that 4. So 4 times 2 will give me 8. 4 times negative 1/8 p will give me negative 4/8 p, which I can simplify down to just negative 1/2 p. And then the right side will be the same. Okay, so again, I just took this 4 times negative 1/8, and I got negative 4/8. And then I could simplify negative 4/8 to just negative 1/2. All right, so now from here, get all of my variables to the left side. So I'm going to subtract 1/4 p from both sides. Okay, so this give me 8 negative 1/2 minus 1/4. This will give me negative 3/4 p is equal to negative 7. All right, from here, I want to get all of my constants now to the other side. So I'm going to undo this positive 8 by subtracting 8. And this will give me negative 3/4 times p is equal to negative 15. And now to finish this thing out, to get p alone, to undo multiplication by negative 3/4, I'm going to divide by negative 3/4. Okay, it'll cancel out on the left, so I get p is equal to negative 15 divided by negative 3/4. Anytime we divide by a fraction, make sure you put that in parentheses. So negative 15 divided by negative 3/4, and that will give me a positive 20. So p will equal positive 20. Okay, so now we got a few special circumstances whenever we are solving these multi-step equations. So a lot of times we're going to get answers that look like x equals 4, p equals 20, variable equals constant. But there's going to be a couple cases where that doesn't happen. Okay, so if the variables cancel from the equation while solving it and it yields a true statement, it will be known as an identity. Or we could call this an all real numbers solution. Okay, now what I'm talking about here, okay? So let's say in the case of maybe I have something like 2x minus 5 equals 2x minus 5. Well, with this equation, we want to get all of our variables to the same side. So I would subtract 2x from both sides. 2x is canceled out here. I get negative 5 is equal to, and here's the thing, the 2x is canceled out over here as well. So I'd get negative 5 equals negative 5. Now notice, my x's are gone. I don't have any more x's. All I'm left with is negative 5 equals negative 5. Well, negative 5 equals negative 5. This is called a true statement because negative 5 is equal to negative 5. So in the case of where your x's, your y's, whatever your variable is, if it cancels out and you're left with a true statement like negative 5 equals negative 5, then that means that your solution is all real numbers. And what this means is that we could take any value that we want to and plug it in for x, and it would work. We could plug it in and we would get a true statement. Like up here. When we were checking it, we plugged in the value and we got it down to a true statement. Negative 1 equals negative 1. So with an identity, with this type of equation right here, then anything we plug in for x. So if we plug in positive 1, negative 2, positive 3.5, negative 15 over 2, we can plug in whatever we want and we would get a true statement. So that's why all real numbers applies here. Now the flip side, if the variables cancel from the equation while solving and it yields a false statement, then the solution is no solution. Or another way we could put this is that we get what is known as a contradiction instead. Okay? So, for an example in this case, 2x minus 5 equals 2x plus 5. Okay, we go through the same process. Get the x's all on one side, so we're going to subtract 2x over here, which means we also have to subtract 2x over here, and we get negative 5 equals positive 5. Well, here's the thing with this statement. Negative 5 does not equal positive 5. So in that case, we would put a slash through that because negative 5 doesn't equal positive 5. Okay? This right here would be a false statement. So then the solution to this equation, 2x minus 5 equals 2x plus 5, would be no solution. And in this special case, that means that it doesn't matter what we try to plug in for x, it wouldn't yield us a true statement ever. So if we get rid of all of our variables and we're left with a true statement like negative 5 equals negative 5, then our solution is all real numbers. X equals all real numbers. If we work it out and we get a false statement when our variables cancel out, negative 5 does not, or negative 5 equals 5. It does not equal 5. So then, and I guess we would say x equals all real numbers here, x equals no solution here. There's nothing we could plug in. All right, so let's look at a few of these examples. All right, number 3. Negative 3k plus 5 times 6 minus k is equal to 4 times 1 minus 2k. All right, so we need to simplify this. So we're going to get rid of the parentheses. on both sides. All right, so with this first one, negative 3k, we're going to rewrite because we haven't done anything to it. We're distributing a positive 5 to everything in the parentheses, so that's 5 times 6 will give me 30. 5 times negative k will give me negative 5k is equal to, this time we're distributing 4. 4 times 1 will give me 4. 4 times negative 2k will give me negative 8k. All right, so now, look on the left-hand side. Anything that is a like term will combine. So we'll take negative 3k and negative 5k, combine that into negative 8k, because negative 3 minus 5 is negative 8. And this will be equal to 4 minus 8k. All right, so now from here, we want to take all of our k's and move them to the left side. So to get this negative 8k away from the right side, we're going to add 8k instead. So anything I add to one side, I have to add to the other. So 8k's cancel out over here. I'm left with 30 is equal to 4, and then the 8k's cancel out over here. So I get 30 equals 4. Well, 30 does not equal 4. This is a false statement. So our solution is no solution. All right, let's look at number 4. 3 plus 4 times x plus 2 is equal to 11 plus 4x. All right, so we need to get rid of these parentheses. This time we're going to distribute a positive 4. We know that it's a positive 4 because we look at the sign in front of the coefficient. So distributing a positive 4, we get 3 plus 4 times x is 4x. 4 times 2 is plus 8 equals 11 plus 4x. All right, going to combine any of my like terms on the left-hand side. So we got a 3 and an 8 that we can put together. So we get 4x plus 11 equals 11 plus 4x. I want to get all of my variables on the left side, so I'm going to undo plus 4x on the right by subtracting 4x. Anything I do to one side, I got to do the other. So I get 4x's cancel out, 11 equals 11, 4x's cancel out. So I'm left with the statement 11 equals 11. Well, this is a true statement. 11 does equal 11. So my solution will be all real numbers. All right, number 5. X minus 5 minus 3x equals 7x plus 4. All right, so first up, get rid of the parentheses by distributing. Now, with this one, there's no clear number that is in front of that parentheses. The only thing that's there is a negative sign or a minus sign. So in this special case, we can assume that the number in front of the parentheses is a negative 1. So negative 1 is what we are distributing. So we're going to have x, then we have negative 1 times 5 will give me negative 5. Negative 1 times negative 3x will give me positive 3x. And this will be equal to 7x plus 4. All right, so from here, we're going to look on our left-hand side. Is there anything that we can combine? We have an x and a 3x, so we'll combine those. X and positive 3x give me 4x minus 5 equals 7x plus 4. Okay, I'm going to move all of my x's to the left-hand side. So get rid of the 7x over here by subtracting 7x. Anything I do to one side, I have to do the other. So I get negative 3x minus 5 is equal to 4, because those will cancel out. Okay, we're going to get all of my constants to the other side. So to undo negative 5, we're going to add 5. Just give me negative 3x is equal to 9. To finish this one out, get the x alone, we're going to divide by negative 3. So x will equal 9 divided by negative 3, which will give me negative 3. So this one was like the ones we started with, okay? So there wasn't a no solution or an all real numbers. We still had an x at the end. So this one, the only value that we could plug in would be x equals negative 3.